Hello, today I'm going to be going over integration by parts. So, some Calc 1 students may come out of calculus and knowing what integration by parts are, some may not. Depending on who your instructor was, you may have gone over this, you may have not. So, an integration by parts is just a way to integrate more complicated expressions. When you were learning off integration, there was really no way to solve an integral like these, because you were learning to do simple integrals. So what integration by parts is you have this expression that you can break down into u and dv. Now the u, then again, the u could be like x squared cosine x divided by 2x, and the dv could be something. They're just used to represent expressions. You're substituting. And so you can use, and what the integration by parts formula tells us is that the integral of u dv is equal to v u minus the integral of v du. Some people remember this as voodoo or voodoo, because if you can rearrange the du and the v, it could be spelled out voodoo. I just remember it as the formula. So what this means is that, coming over to this expression, I'll show you an example. You want to pick something to represent your u, and you want pick something to represent your dv. And so you typically want your u to be something that will break down easily by doing derivatives, because if you'll notice in this formula over here, we take the derivative of u. So I'm going to pick x squared to be my u, because the derivative of x squared is just 2 times x. And you'll get a better understanding of why I picked that in a bit the further along we go in this problem. And I'm going to pick my dv to represent e to the x dx. So now I figure out the derivative of my u. In this case is just 2x dx. Don't forget to write that dx, because some instructors will mark off points for that. And then the v, and then you just take the integral of your dv, and the integral of e to the x dx is just e to the x. Alright, so now what this means is the integral of x squared times e to the x dx is equal to my v times my u. So I'm going to write x squared e to the x, or my u times my v, doesn't matter, minus the integral of my v times my du. So then that means my e to the x times my 2x dx. And so now this integral looks a little simpler. And if you remember from Calc 1, you can bring any constants outside of the derivative. So I'm going to move that 2 outside. So now this looks a little bit simpler, but we still have the same problem, because this isn't a simple integral. Because the point of integration by parts, or any complicated integration technique, is to break these integrals down into simple integrals. So we'll have to do integration by parts again. And again, we want to pick something that will break down easily with our derivative. And by break down, I mean that, like, if we keep taking the derivative of it, we will eventually get to a constant. So like if I have an example being like if I have x cubed, if I keep taking the derivative of that, I will eventually get a constant. It'll be 2. Or if I keep going, not 2, it'll be 6. If I keep going further, I will get to 0. Like if I take the derivative of this 4 or 5 times, I will eventually get to 0. That's what I mean by something that'll break down easily. So I want to pick my u to be my x. I want to pick my dv to be e to the x. Derivative of x is just dx. And the integral of e to the x, oh, forgot the dx. Don't forget that dx, because some instructors will mark off points for that. Integral of e to the x dx is e to the x. So now what this means is that this whole, I'm going to continue off this whole integral up here is equal to x squared e to the x minus 2 times, and this is where that integration by parts we just did right here comes into play, x e to the x, because v times u, or u times v I guess in this case, minus the integral of v, our v value, times our du value, which is just e to the x dx. And hey, we've been doing the integral of e to the x dx this whole time, so we know what that integral is. So this is now broken down to a simple integral, and then we can just go ahead and solve it. So we can say this is equal to x squared e to the x. We can distribute this negative 2 minus 2x e to the x. And so we distribute it again. That's a positive. No, it's a negative right there, so it's going to make it a positive, excuse me. Plus 2 integral of e to the x is just e to the x. You can't forget our constant of integration because it's an indefinite integral. So this is our answer to the integral of x squared e to the x dx. We use integration by parts to get there. And thank you for watching, and I hope to see you again in another video.